Hello everyone. This video is about the instruction formats in a computer organization and structure. It's COA. It's to execute a particular instruction in processor. We have four different type of formats. Means a single instruction can be represented in four different ways. Each representation have its advantages and disadvantages. What is the instruction format? Instruction format means sorry, how an instruction is represented within the processor. What is the instruction when we are doing the a plus b, we are giving 10 plus 20. So we are saying to the processor that perform the addition of 10 plus 10 and 20. That means we are instructing the processor to perform the addition of 10 and 2. So how this instruction is represented in the processor. So because of the processor understands only the language of 0 and 1, not the English. So how it is represented? So out of these four formats, first you can see that there is a zero address instruction format. In zero address instruction format is also called the stack organization. You can see that this is a stack organization. Why it is called the stack organization? Because it uses a memory stack. What is a stack? If you have ever seen the pile of books in the library, or some books above books above books, pile of books vertically, so that is a stack. A vertical pile of books is a stack. You can take back from the top and you can push a book on the top, so that is top of the stack, which we are saying here toss. So in the stack there are two operations, push and pop. Push to push the data on the stack, and pop to take back the data from the stack. So here in this table, the stack is shown to evaluate any expression in zero address. I have deleted this as the previous. I have used this as a long example where things become typical for the being safe of easiness of explanation. I have used only y equals to a plus b into c plus d. In zero address instruction format, we first have to convert the given expression into postfix notation. In postfix notation, operator or whatever operation is to be being performed goes after the data. Is a and b is data, and operation plus will go after the data in postfix notation. That is post means after, जो आने वाला है. So a plus b will become the ab plus, c plus d will become the cd plus, and star is after that. Why we have performed first a plus b? Because it is within the bracket, and in operator precedence, priority of the brackets is highest. Then the priority of multiplication operator goes above the plus. Okay. So now in postfix notation, our expression becomes y equals to ab plus cd plus star. Now we have to operate this representation in zero address instruction format. For this, first we will push the a, so the top of the stack will become a. Here you can see what is ma. Ma represents the memory address where the data A is stored. In the different text, in the different references for the different authors, some authors say that MA is the memory address of A. Some can say that MA represents the data, exactly the data, but here I am saying that MA is representing the memory address where the data of A is stored. It is a way, there could be a different way. So for the sake of simplicity, push A means just we have pushed the A on the stack. After that, push B, because in postfix there is AB. Okay, after that there is plus operation. So for the plus operation there is an instruction add. What this instruction add will do, it will add the A and B and will store the result here again on this place. This is a minor point. When A and B is added, so A plus B will not be stored here. A plus B यहाँ पर स्टोर नहीं होगा, मीन्स टॉप ऑफ द स्टैक रेज नहीं कर जाएगा. ऐसा क्यों? क्योंकि ए प्लस बी ऑपरेशन करने के बाद आफ्टर इवेलुएटिंग ए प्लस बी वी डू नॉट नीड ए एंड बी एनी मोर. हमें ए और बी की अब नेक्स्ट अगेन ज़रूरत नहीं है. अगर होती तो हम उसको टेम्परेली कहीं स्टोर कर लेते. सो we are storing the A plus B at the bottom of the stack, and we are creating it as a toss. In stack organization, toss is the main thing. Top of the stack is a pointer, and where this pointer will point, our operations will be performed from here to upwards. Where the top of the stack will point, our operation will always be performed from there to upwards. So after evaluating A plus B, there is CD plus. So for this we have push C, then push D, again there is add. So there is what this add operation will do, we have pushed C, we have pushed D. Now the C add C plus D operation will add the C and D, and will C plus D will be stored here. It will not be stored here. This is a minute thing. Okay, C plus D will not be stored here. C plus D will be stored here, because we do not need the C and D anymore here. Okay, so now we have only C plus D and A plus D in our stack. Rest everything is our default values and of no use. Now as an expression, so we have done this much. What remains? There is star operation, the multiplication operation. For multiplication operation we have mul instruction. If in some example you have a division operation, so there is a div instruction, and if there is subtraction, then there is a sub sub instruction. Your numericals come all over these instructions, not beyond of this. So mul top of the, now after multiplying C plus D and A plus B, top of the stack becomes A plus B into C plus D. What is the calculated? The calculated value of A plus B into C plus D becomes the top of the stack, which is the Y. Okay, so now top of the stack contains the Y. Okay, top of the toss, which is a pointer. We must understand the toss. Toss, top of the stack, is a pointer. Okay, wherever it will point, our stack will be evaluated from there to upwards wherever it will point. So top of the stack is currently pointing to the a plus b into c plus d. Okay, now entire expression is evaluated, and we have our value. This value will be popped out from the stack. So the pop operation is used. Pop operation is used to get back the evaluated data from the stack. So this is the expression of zero address instruction format. In next three videos, one address, two address, and three address instruction formats will be explained. I have not made in this single video for making the video smaller. Thank you.